All right, so let's go ahead and look at a course to steer problem. This is going to be section D on your problem set, course to steer. And we're going to go ahead and look at question number 1. So we're going to take this data, plot it on the chart. There's going to be 3 answers to this. We're going to find the course to steer, the speed made good, and the vessel's estimated passage time. Again, in this problem set, they've presented us the data in an easy to access table. So we're going to work from left to right. And if you get stuck, just try to look at that next piece of data and decide what to do with it. So for our course to steer, the first step is going to be to find our start position, 29 degrees and 45 minutes south, 31 degrees and 15 minutes east. Conveniently, in the first problem, they've given us a nice easy point to find. So here's 29 degrees and 45 minutes, this line of latitude. And we're also looking for 31 degrees and 15 minutes east, this line of longitude. Again, no official chart symbol for our starting point. I'm just going to go ahead and put a little dot there as my starting point. If there were a time given, you could note that. However, in this problem, there is not. The next thing they give us is a destination. So in our course to steer, we're always going to get that start point and destination. Now, I'm looking for a wreck in the vicinity of Mshlanga Rocks, which is going to be just to the left here. This is Mshlanga Rocks with the lighthouse, and then this symbol here, the dotted circle with the WK next to it, is going to be the wreck. There's a little bit of leeway in your answers again, because in real life you might know where you want to go. Do you want to be right on top of that wreck for fishing, or do you just want to go to the outside? In this case, I believe the answer key kind of just takes you to that nearest corner. But if your passage time is a little bit different because you went here instead of here, that's not a concern. If you didn't know what a wreck looked like, you can always get out your Admiralty publication NP 5011, which I'm sure you look at, but that's going to be your chart symbols. So first step in this problem is going to be to go ahead and connect up those 2 points as mentioned. This is the line I actually want my vessel to follow, so we're going to call this the ground track. Technically, I'm driving in that direction. Now, the ground track in any problem where one is present is going to get 2 arrows, 2 feet on the ground. Next piece of data they give us is going to be the current set or direction, and then the current rate. Now, this is oftentimes where I see a pretty common mistake made. So we're going to go ahead and find the direction of current, which is going to be 030 degrees. So that's right out here on the outer circle of your compass rose. So per normal, we're going to go ahead and line up our rules with the center of the compass rose and 030 accurately at the same time. And just make a quick note for me. Every direction on the compass has its opposite or its reciprocal direction. So for this example, the current is taking us from the middle towards the top, towards 030, kind of like north-northeast. It's not taking us from the middle down towards 210, kind of like south-southwest. So make sure that when we transfer this bearing over, we come to our start position. And for a course to steer, that current's always going at the start because we're anticipating the effect. And we're going to draw its effect towards the north-northeast, towards 030. If you were to draw it this way, that would be the opposite current, and that would be incorrect. So there's our line representing our current. Current vector, anytime it's present, is going to be given 3 arrows as a standard chart work symbol. And then they've given us the rate or speed that current was pushing us at. For this problem, that's 2 knots. And again, I always like to work in a 1-hour interval for these problems because that's going to make my math nice and easy. But if distance is equal to speed times time, in that case, the current over the course of 1 hour is going to push me 2 nautical miles per hour for 1 hour. Yeah, that should be pushing me 2 nautical miles. And if you can do that in your head, that's great, but we'll make sure we get the math right. Okay, so here's 2 nautical miles on my latitude scale. No official chart symbol here, but if I was just sitting stationary in the water, the current would push me this far in this direction. I'm just going to put enough of a mark there that I can see it, but no official chart symbol there. And I'm going to go ahead and just shorten that line down to that mark. Give me a nice clean current vector. Okay, next piece of data they've given us is boat speed, and this is kind of the crux or the key point with our course to steer. Our boat's capable of traveling at 5 knots through the water for this problem. So I'm going to go ahead and measure out that 5 nautical miles right here on the latitude scale again. 45 down to 50, that's 5 nautical miles. We'll be nice and precise. And where am I going to put that? Well, the boat speed is always going to go on the water track, and I don't have a water track yet. It would be tempting to put it on this line, but that's your ground track, which is your speed made good, the distance and or speed that you're actually making towards your destination. And instead of putting it there, I'm going to take one arm of my dividers to the end of that current vector and swing them until I find the point where they meet that ground track. And given my 5 knots of boat speed and my 2 knots of current, this is the course that I need to steer in order to stay on my ground track. So no official chart work symbol there. Just make enough of a mark that you can see where that connects. And then we'll go ahead and draw in that last line. Water track gets 1 arrow. And at this stage, we have a course to steer, but we do have one more variable that's going to affect it. That would be our direction of travel if we didn't have wind, but the last thing they give us is wind and leeway. So in this problem, the wind is coming from the northeast. That's, roughly this direction. And we're going to do the opposite of what we would have done in a estimated position. The wind is trying to push us 5 degrees off course. So we're steering this way to make our destination. If we allow the wind to push us down, we're not going to get to our destination. So instead, the final step in this problem is to take that water track and make an adjustment 5 degrees towards the wind. So let's do that accurately. I'm going to go ahead and line my rules up with my water track. I'm going to go ahead and transfer them up to my compass rose. Again, you've got a couple of degrees of freedom on your answers, but you should be in the vicinity of 251, 252. And so let's call it 252. If the wind is trying to push me that way, I'm going to counter steer, and I'm going to steer the 5 degrees required. So that's going to be from 252 up to about 257 to counteract the effect of the wind. I'm going to remember that number, 257, because that is my course to steer. And I'm going to transfer a nice parallel line back to the end of my current vector where that water track originates, because that's the track I'm adjusting for wind. And I'm going to finish my plot with a short line showing my ship's heading. That's my plot complete. However, there's 3 answers that I need to extract from it in this example. The first answer that they've asked for is my course to steer. And specifically, they're going to want it in degrees compass because you want your helmsperson to steer that course. So I had said that it was 257 when I measured it on the chart, but that's degrees true. So we'll set up our normal table, TVMDC. Variation is always going to be 25 degrees west. If you need it, go to that calculator, 257 plus 25, because we are working from true towards compass. And in that case, we're always going to add west. Magnetic is 282. We need deviation. You'll find that on page 4 of your problem set. Here's your deviation card. Now we're given a magnetic bearing of 282. So within that magnetic column, let's go down and find the nearest value to 282 available. That's 284. Corresponding deviation, 6 west. Adding west, I'm getting 288 degrees compass. That'll be my course to steer in ship's compass. Answer number 2. They're also going to ask you for your speed made good. Back here on section D, we need speed made good. So our boat speed, 5 knots, was on the water track. Our current speed, 2 knots, was on the current vector. So the final speed that we're going to extract from this problem is going to be the distance from our start position to the point our water track meets that ground track right there. We can go ahead and measure that out. I'm looking at something like 3.8. So my speed made good is going to be equal to 3.8 knots. Now I took a little bit of a shortcut there, I might have mentioned. I technically just measured a distance, which was 3.8 nautical miles. How long did it take me to go there? 1 hour. So properly, that's just 3.8 knots. But again, if you can do that in your head, that's your answer. All right, last step is they would like to know what's called EPT, or the estimated time of passage, estimated passage time. And that's the total time it took me to go from here to here. Now there's a few ways you can potentially figure that out. You know, if it took you 1 hour to get here, well then it would have taken you about 2 hours to get here and some change. But I think the quickest way to work it out is just to take this total distance. And we'll go ahead and measure that out. I'm getting 7.8, 7.9 nautical miles. And so we're going to want time. Time is going to be equal to distance divided by speed, specifically speed made good in this case. And our total distance, let's call it 7.9 nautical miles, divided by that previous answer, the speed made good, is going to give me my time. So, calculator, 7.9 divided by 3.8, we're getting something like 2.1 hours if we round to 1 decimal place. Now, if you get there, you're doing good, but that's not the usual way that I tell time. I usually tell time as hours and minutes. So maybe for my final answer, that 2.1 hours is the same thing as, let's say, 2 hours and 0.1 hours. And if I remember that there are 60 minutes per hour, if I just multiply that 0.1 times 60, those hours cancel out, and I should find that this is the same thing as 2 hours and 6 minutes as a final answer.